coming to the next topic. So, digital representation of audio. Up to now, we have seen. So, what are the things basic for this elements of that when we are traveling, when we are sending the data from one source to another source, right? So, we have seen all those things. So, what is a continuous data? What is a discrete data? All these things we have seen, right? So now we have reached the topic of digital representation of how the audios are getting, how the audios are converted as a zeros and ones, right? How it is coming as a zeros and ones. Audio is a continuous analog signal representing the sound waves, isn't it? So how the audios means it will come from the speaker. The sound will be like keep on coming. So how the sound will be? It is in the variation of up and down. Again less, again high, again low, like that the thing will go on. So it is a continuous analog signal representing the sound wave. So computers cannot process analog signals directly. Hence, the audio must be converted into the digital form. Already I told you, right? Like this waveforms are to be calculated in the form of digital. Digital means it won't come like this. So how it will be in the sense either 0 or 1, no. So this is 0, this is 1, this is 0, this is 1. If two ones are there or two zeros are there, like this it will travel. It will travel like that. Okay. So 1 1. So these all are zeros. So like that this form will be converted to this form. So this is called as digital form, right? So digital means zeros and ones only. The digital representation enables the storage, processing, transmission, and the to store or process a sound in now the standard continuous analog sound waves must be converted into discrete digital format, that is a binary code, through three step. This called as digitization, right? So I told you, no, this sound will be keep on coming. Now I am talking continuously, I am taking the classes continuously, my sound is coming up and down, the variations will be there, mild variations will be there. I cannot talk in the same tone like a robot, right? The mild variation of up and down will be there, these will be captured and these will be converted as a binary using some format, right? So there are three formats are there. So this is what the thing what I have drawn, no, the same thing only. The sound source will be like this, the pressure will be calculated like this, the analog signal samplings also will be calculated like this. So how they are finding out the digits as a zeros and one? A normal level is there, no? If they are reaching the level going upward, it will be 1. It is going down, it is 0. Like that they will calculate, right? The signal representation of the digits are like this. So continuous getting of the sound will be captured and it will be given as a series of numbers like this. So analog versus digital audio. So what is analog, what is digital? Analog audio is a continuous wave, infinite wave. Digital audio is a discrete ensamples with a finite value, right? So digital audios are noise resistant, easy to store and transmit, suitable for the compression. Why? Analog means when I am talking. So analog audios means like this is a wave format of the audio. So in that, so extra background noises also will be detected, right? So if I am talking in the peaceful environment, then only my voice will be recorded, right? Or else if I am under the noisy environment, there is someone is talking at the back, right? So it is too noisy, I cannot able to convey my words clearly, right? So by the time what will happen along with these words, along with these variations, some more mild thing also will be detected. So like this you might have noticed, right? So this is a continuous wave and it will have the infinite values also. We cannot identify how long the pitch it will go, peak voice it will reach. Yes, how much it will reach the top and how much it will go low, we don't know, right? So it is a infinite value and it is a continuous wave. And discrete samples with the finite values. Here we can identify the samples are how. So either it is positive means that curve will be like this. 1 means this and 0 means this. Like that it will identify the values. So and digital audios are noise resistant means when the audio is detected then it will put this, not this kind of variations. It is easy to store and transmit and it is useful for the compression. See the picture here. So how they have given, see the analog diagram like this they have given, no? So now whatever I have told, the same they have given in the graph. So how they are putting is, so we will be having a graph, no? So graph la we will be having a point. That point la what it is going, where it is reaching. So from there they will put the lines. Okay, so again from here to here, again here to here, again here to here. It is going on like the same thing only given with this example. So same sample we have used the analog, and the analog was shown in the digital form also. Audio signal sampling. So how the audio signals are getting sampled. The process of measuring the audio signal at the regular interval. So what is a regular interval? Here the gap is there. No, this is called as a regular interval. So we need to identify how long the audios are coming in the intervals. So that intervals should be noted. So according to that intervals only we are measuring the audio signal, and it converts the time continuous signal into the time discrete signal. So what is a time continuous signal? The signals which is coming in time. Yes, it is coming frequently in a flow. So it converts that continuous signal into the time discrete signal, that is like a zeros and ones it is converting. It is governed by the Nyquist sampling theorem, right? The sampling frequency must be at least twice the highest signal frequency. So the normal frequency, sampling frequency, how it will be means, it is a twice the time of the highest signal frequency. It at least twice the highest signal frequency. So what is a bit depth? So what is a bit here? Either a 0 or a 1 is called as a bit, right? The bit depth defines the number of bits per sample. Each sample, how many bits we are sending. It determines the dynamic range of the audio. The common bit depth means 8 bit is a low quality, 10 bit means CD quality, 24 bit is a studio quality, right? So like that, the bit qualities are getting more and more to improvise the quality of the medias. And what is a numeric instruments? So this is also another topic. So what is a numeric instrument? So wherever the numbers are used to measure and convert and process the physical signal, they are called as numeric instruments. Okay, they play a vital role in digitizing the multimedia data, right? So digitizing means, so whatever the multimedia, we are going to convert them into a zeros and ones. That is called digitizing, right? It is used mainly in audio, video and the sensor based system, right? Enable accurate numeric representation of real world signals, right? Enable the accurate numeric representation. So what do you mean by that? Accurate value means, so it's exact value, right? So some place we cannot get that exact value, that variations we cannot identify and we cannot put it in the graph, we cannot accompany them in one place. So this accurate representation of the real world signals, for that this is very helpful. The topic what we are going to see is numeric instruments, right? So what is a numeric instruments? Numeric instruments are the devices used to measure, convert and process the physical signals. So what is a physical signal here? So physical signal in the sense I have told you, like, so whatever the signals I am receiving. So mostly the audio signal only we will receive. So audio signal means this one only, right? Waveform. So when I am talking, the voice will travel in the air and it will come, no? So this is called as analog signal, right? This analog signal should be converted to the digital signal. That digital only will be saved in the computer. So used to measure, convert and process the physical signals. They play a vital role in digitizing the multimedia data, right? So it is mainly used in audio and video and sensor based system, right? So why we are using it is like accurate information we need to get, right? So what is audio is about, how much voice I am getting. So all these things, like the numeric representation should be accurate. So it will be connected with the real world signals. So what is the meaning of this numeric instruments? It represents the physical quantities in numerical form, that is in numbers, right? So 1, 2, 3 numbers, right? Numbers are called as numerical forms. They converted the analog values into the digital values. Example, sound pressure, light intensity, temperature, and it is essential for the multimedia data processing. So analog signals always it should be converted into a digital numbers, right? So that numbers means how it will be sound pressure, light intensity, and the temperature. So always the temperatures will be, you know, the temperature, no? So it will show like a 21 to 16 like that. It will show the temperature. No, this temperature value will be converted into a digital again. So types of signals. So see how they are varying that in the graph. We used to have the positive on this side and the negative on this side. So 0, 2.55. So the variation was 2.5. So 2.5, 2.5 they are varying. So how the sound signals are going on within that base they are drawing the graph. So this analog signal as such, it will be converted into a digital signal. How? Where it is reaching the maximum point, it is 5. So 5 la they are keeping a line and putting the line and marking it as 1. So here, what about here? Here also it reached up to this extent. So up to this extent it reached. So it is also 5. So up to 5 they are marked, right? So 0, next one, like that it is keep on going on. So what is the role of multimedia system in this? Right? It enables audio and video digitization. It is used during the signal capture. So wherever they are capturing the signals, that time like, it will be very helpful, right? And signal processing, storage and the transmission, right? It provides accurate input for the multimedia application. So for this is the reason we are using the multimedia systems here. Analog to digital converter, ADC. So analog to digital converter converts the analog signals into the digital form, right? Analog signals means already I told you thing which we are talking, speaking on all, no? So the waveform we will get, that form will be converted into the digital form. Core numeric instrument in multimedia, this is a core instrument. So it works through the sampling, quantization and encoding. So these are the methods. So using these method only we are working on it, right? So this concept is used in microphones, cameras and sensors. So microphones are nothing but the mics. So which we are holding the mic. If you are holding it very closely, the voice will be more audible, more high, more up and downs we will get, right? The same thing, cameras also as well as in the sensors also. So digital to analog conversion. So it converts the digital signals back into the analog form required for the audio and video playback. So once the picture, once the thing is getting converted into one form, it should be converted to the another form. So why in a sense? So consider this is a mic. The mic is emitting a signal. That signal is coming in this form. This form is converted as a binary waveform, this form, right? So it is getting saved in the system, saved in the computer. It's getting saved in the computer. So when you are taking back again from here, we will get a digital only. So this digital we cannot understand. So again we need to reconvert that into the waveform. Then only we can understand it. The DAC converts the digital signals back into the analog form. So it is required for audio and video playback. When we want to play it again, so that time we need to do the reverse process. So used in speakers, headphones and the display systems, right? So sampling instruments. So what are the sampling instruments? So these are used to capture the signals at a regular time intervals. Sampling accuracy affects the signal quality. So poor sampling leads to aliasing and the common in audio recording device. So what it is, what they are talking about. So sampling instruments means just they are putting us capturing the signals at the regular time interval, that is called as a sampling interval. Okay, just they will be see the sample of the intervals. Sampling the accuracy affects the signal quality. Sampling, if it is not having that accuracy, it affects the signal quality. Poor sampling means it will be, if you are taking the poor one as a sample, then the quality of the video will be, it is common in audio recording devices. So audio recording devices means what are the devices? In our phone we used to have a voice recorder as well as mics where it is connected to the other devices to store. So these are the things. And then measurement accuracy and precision. How the measurement is accurate. So accuracy means it is close to the true value, that is exact value, right? Accurate, 100% accurate means it is 100% exact value. So precision, repeatability of the measurement, right? Precision means repeatability of the measurement. So precision means always after the dot we will be having a value. No, that one is called as a high precision will improve the multimedia quality. Whenever we are having the precision, this precision should be high. Then it will improve the multimedia quality. It is affected by instrument resolution, noise, and the calibration. Right. So when we are having a problem with your device, then the thing will be affected, and because of some external noise, that is noise around us, it will be affected, and calibration in the sense just because of the disturbances, right? So suddenly it will get some kind of disturbances, so because of that disturbance also it will be affected. Then so noise and error handling. The noise distorts the original signals. Numeric instruments use filtering, error correction, oversampling, reduces the distortion in audio and video. What is that distortion? Right? So noise distorts the original signals, means so because of some other noise around us, it will affect the our audio or a video, whatever it is, it will be affected. That normal audio and video will be getting disturbed. So this noise distorts the original signal. Numeric instruments use the filtering, error correction, and oversampling. Okay, filtering, error correction, and oversampling. It reduces the distortion in the audio and video. So we are having some instruments, yes, numeric instruments like a filtering, that is filtering of the background. Sometimes people will say, no, like videos will be edited. So why they are editing the videos? So wherever the unwanted things are there, that they will reduce, they will delete it. Those portions will be cut, that audios will be removed, all those things. After that, we will get a clarity, accurate pictures we will get, right? So error correction. So something might be the error. That error will be removed. And then oversampling. So oversampling in the sense like advanced things they will add more, and they will might be like they will get a clear samples against that, right? So after doing all these things, the distortions will be reduced in the audios and videos. So use of the numeric instruments in audio. It converts the sound waves into the digital samples. So from that time onwards, we are seeing that one only, sound waves into digital samples. So control in the sense the sampling rate is there, bit depth is there. So according to that, it will be controlled. So ensure the high quality audio representation. So always the high quality audio representation should be right used in microphones and the sound cards. We will use all these things in the microphones and the sound cards. So use of the numeric instruments in video, how they are using in video to measure the light intensity of each pixel. Audio means there is no point of thinking about the pixels. But video means we need to see the pixels as well as the audios. It converts the visual data into the digital form, right? So it converts the visual data into the digital form, and it is used in cameras and scanners. What it will affect? It will affect the image resolution and the color accuracy. This is what we will say, like in picture we are having a different color of picture of the photo, dress or something, and in real life we'll be having a different color of the picture. While ordering in the online, they will mention like the color of the product will vary according to the resolution of the picture, like that they will give, no, so all because of this one only. Color accuracy will change according to the system to system. Performance consideration. Speed of the conversion will be good, and the resolution and the dynamic range is good, and power consumption also good, the cost and the reliability. These all are the things called as performance consideration. So why we are telling the speed of the conversion means it is very fast. It is fastly converting the thing from one source to another, right? And resolution and dynamic range. So the resolution of the product is getting changed and within the dynamic range, right? So power consumption also will be good. The cost and reliability also will be very good. So these all are the performance consideration. Then for examples of this numeric instruments was given. So ADC and DAC chips. So ADC means to digital converter, DAC means a digital to analog converter. Okay, this one will convert from this to this one will be reverse. Digital oscilloscopes, digital sound cards, image sensors. So these all are the example where they are using this convert the digital source to analog source as well as the analog source to digital source. So next topic what we are having is digital interface. So up to now we have discussed something about that, right? And what is a digital interface? So interface means what? It is a place where we are getting to interact with others, right? So a digital interface enables a communication between the digital devices. So when we want to communicate with one another, we need an interface, right? So digital interface is a place where it is communicate between the digital devices, right? It acts as a bridge between the hardware, software, and media components, right? What is a hardware? The hardware is a physical components which we can touch it. What is a software? These are the programs and the media components. What are the multimedia components we are having as a extra, like a camera or a mic or digital cameras, like taking a videos as well as the audios, no? Those things are called as media components. So when we are connecting all these things, we need a bridge to communicate with between both, right? So for that we need a digital interface, right? It is essential for data transfer, control, and the interaction in the multimedia system. So it is mainly important. Without that, we cannot able to communicate with each other. Ensures the compatibility between the different system components. So it will make sure like it was connected with other components or not, whether it is perfectly connected or it is able to connect, communicate with others or not. Then the meaning of the digital interface. So digital interface is a set of rules and standards for data exchange. So what it is? So when we are having an interface, that interface is communicating with it is like a bridge between both the devices. This side one device is there, this side one device is there. It is acting as a bridge, but it should have also have a standard rules and regulations, right? So it defines the data format. It is very, very important, right? What is the format of the data? So what is a data format means, whether it is a text or a number or a image or a audio or a video. So if it's a image, again it is a JPG or GFF or TIFF and PNG, BMP, like that. So many formats are there. No, what is a format about? If it's an audio file, it is a MP3 or a MIDI, like that. We are having a formats. No, so first we need to find out the data format. Transmission method. So what kind of transmission we are doing? So from what to what we are converting? If it's a text, we are going to convert it into binary. If it's a number also, we are going to convert it into binary, right? So if it's an image, then the image will be in the form of pixels. That pixels to be binary. Then again, next one, we are having audio. Audio means waveform, analog to digital, like that. What is the transmission method we are going to do, and what are the control signals we are having to make sure that confirmation is doing properly or not. It allows the different devices to work together smoothly, right? So many devices are getting connected in one path, so it is making all the devices to club and work peacefully. So need for digital interfaces in multimedia. So multimedia systems uses multiple devices. So it will use always multiple devices only. Interfaces enable the fast data transfer, accurate media exchange, and the device coordination. Without interfaces, devices cannot communicate, right? So without the devices, without the interfaces, the devices are not able to communicate with each other. So this is a main thing about this, right? So using this interface, we can do the fast data transfer, accurate media exchange, and the device coordination, right? So hardware digital interface. So what is a hardware? It is a physical component of a computer which we can touch and feel, right? So used for the physical connectivity. So physical connectivity means whichever it is available in front of our eyes. That is called as physical connectivity. So example, USB, HDMI and VGA. So display port. So carries the audio, video and the control signals, right? It is responsible for doing all these things. So software means what are the software components we need? Software components are like just a communication between the components. It includes API, device drivers, multimedia frameworks. It allow application to access the hardware functionality, right? So it allows the application to access the hardware functionality. To access the hardware, we need a software, right? So that software to be installed first, then only it will access the hardware. So when there is a, like when you are installing some Wi-Fi connection in your home, so they will install some software in your system to access that Wi-Fi connectivity. So Wi-Fi device is a hardware. So when you are they are installing some software to access, no, that software is mandatory to communicate with that particular hardware. So these are the things in this. And then audio digital interfaces. So up to now we have seen some other devices, interfaces. So for audio transfer, what are the things we need? Sound card interfaces, USB audio, Bluetooth audio, and it supports a digital audio formats and synchronization. Video, for video, whatever we need, HDMI we need, display port we need, DVI we need. Yes, these all are the ports which will be there in the CPU. Connect the external device, that is a hardware, to the system. So it is used to transmit the digital video signal, supports high resolutions and synchronized audio video output. So data transfer we are having some standards. So interfaces follow the specific standards. The standards defines the data rate, encoding and the error handling. So ensure interoperability between the devices. That is, both the devices are working or not in a proper way of working or not. All these things will be identified from this. User interaction interface. So who are the user? We are the user, right? So we are the user who is interacting with the system. So it enables the interaction between the user and the system. So examples: keyboard, mouse, touch screen, gesture interface. So with the help of this, we can use the multimedia system very effectively. So for this is a reason we are always having these kind of devices communicate with the system. Compatibility issue. What is a compatibility issue? When the device is not compatible, then software is different or else your hardware is not acceptable. So by the time we will get a compatibility issue. That means that different devices may follow different standards. So I'm having a software for one particular brand only, means that brand only I have to use, right? So if suppose Act Fiber person is coming and installing their software, means their device will accept that software only, right? So no other device will support that particular software. So interface mismatch causes. So when the interface is not in this kind of standard, then there will be a mismatch. So up to that mismatch, what and all the things will happen? Data might be lost, the device might be failure. So what is the solution? We need to have an adapter and we need to have some universal standard to avoid all these mistakes, right? Data loss as well as the device failure we need to avoid. So for that we need to have this as a solution. What is the role of the digital interface in the multimedia system? It enables integration of audio, video and the data. It supports a real-time communication. It maintains a synchronization and the performance essential for the networked multimedia. So what is this? It enables the integration of the audio, video and the data. Supports a real-time communication. So whenever we are having a real-time communication, like direct contact, then we can communicate with the systems directly. Maintain the synchronization and the performance. So performance and the synchronization should be, right, essential for networked multimedia. Then when there is a network, then only we can be able to communicate with everything very fastly and effectively. So examples of digital interface: USB, HDMI, Ethernet, Bluetooth and the Wi-Fi. So these all are the digital interfaces what we are using in our current world. The next concept what we are going to see is bar. What is a bar concept? There is another name for the bar concept. It is psychoacoustics. Okay. So what is that? So bar concept means it is based on how the human ear perceive the sound frequencies. Yes. So with the ears only we are receiving the sounds, right? Yes. So how the human ears are receiving the sounds? With that only it is working, right? It is this bar concept is working on this, like how the human ear perceives the sound frequencies, right? We are using here, we are having a bar scale and the critical bands. Using that one only, we can identify how the human ears can receive the signals. So it can group the frequencies by perceptual similarity. If you are hearing a word, similar word, then next time, whatever the word you are hearing more likely to the same word, you will assume that this is the same word, right? So for example, his, this. So it pronouns same, right? So every time you are receiving the word this, then if the person is telling his also, you might have received as a this one. All are like it is according to our ear, right? So we will assume that some words in our mind. The perceptual similarity, we will do that, right? So it helps to identify the sounds like a humans, and humans can and cannot notice, right? So when I am talking with some other person, someone is talking with me, I won't be able to identify what they are talking, right? Understand. I want to see also. Like when I was busy in talking to others, if someone is talking, this communication will be lost. Whatever this person is talking to me will be, it won't reach my ears. It is waste, right? It is just waste of time. The same, this method is used to identify what this person is talking as well as I am talking also. It is able to identify and record, right? So enable the audio compression by removing the less perceptible sounds. So what are the other sounds are there at the background? It is a capable of removing all those unwanted noises. So improve the efficiency of the audio data streams in multimedia system. So important alongside other multimedia elements are text, images, video, and the animation. So what is this concept about? So the study of how humans perceive sound, right? So this psychoacoustics means it's a study of how the human perceive the sound. That is how we are receiving the sound. So Bach scale means what? It is a perceptual scale that groups the frequencies into critical bands. Okay, critical bands mimicking the ear's frequency resolution, not linear like hertz. So that much of sound it won't, not in the measurement of hertz. It will observe the frequency and it will mimic the ear's frequency. How much our ears can mimic, ear can hold, that much it will mimic, right? It is mimicking means it's just like a copy, right? It will do like a copy and it will find out the value and it will be giving the particular value. So what is a critical band about? The frequency ranges where the sound interacts and perceive as a single auditory event important for masking. That is louder sounds hiding softer ones. So when I am talking, if someone is shouting aloud beside me, then that sound will overlap my sound. This critical bands will like it will identify the perceived as a single auditory event, right? So important for masking. So where the sound is very important, that sound it will mask and it will keep. How the bar concept we are applying to the multimedia. So first thing, audio compression. So audio compression means what? When audio is there, I'm unable to send that audio by WhatsApp or a mail or something else. I want to compress it. Yes. So compression means what? The larger size to smaller size, right? That is what called as a compression. So the compression, when we are doing a compression, we need to use the bar concept to find psychoacoustically model audio, removing the sound that are masked and less critical to the human hearing, significantly reducing the file size without major perceived quality loss. So without deleting extra data, in the data, whichever is not required, that portion only they will delete. Right? So that is called as audio compression. Audio data stream means what? It understanding the bark allows for efficient and digital representation and transmission of audio as it quantifies how much information is actually needed to represent the sound perceptually. The thing is, how much data information they needed actually to represent the thing, right? So that can be done by the audio data streams. And the sound design, how it will be, it helps in creating effective sound effects and musics by understanding how different the frequencies combine and affect the perceptions. So here all about the perception only, how much a human can hear, can bear. So if you are using a earphone, whatever the sound is there, it is coming, but the phone is indicating that it is more high. It is showing, no, it is indicating that it is more high. this volume is more high, reduce it. You are using the maximum usage of the volume. It is there like that. So we need to, this model is making us to understand. It is like a ability to mimic how much our ear can bear. According to that, it will adjust the values.